just tell me what is time? समय क्या है?
So every single event in this universe is described by these 4 numbers, okay?
What if someone is traveling at the speed of light? What happens then?
Time totally stops for you. Everything is right now. Past and future doesn't exist. I was watching one cartoon, there was one episode on that, on theory of relativity.
Which cartoon was this?
It was Doraemon. Yeah. If you go like 68 million light years away from the Earth, and if you just point out to some hypothetical telescope, let's say, and just point on Earth, you will be looking at the dinosaurs. The creation of the universe is the creation of time.
It's something we can't imagine. What happens once Big Bang happens? And why Big Bang happened? Like, if in just brief, if we want to understand, okay, what was Big Bang?
Big Bang is the start of that tug of war.
Past, future, and the present all hanging at the same time.
Exactly.
Whatever happened for the last 40 minutes, where are they? Where are those moments?
Even there are some people ask questions like, is there a moon if nobody watches it? Is there a moon? Of course it is there. What happens if the moon doesn't exist?
What happens?
Tsunamis will come,
I mean, what's space like? What's space for you? I mean, do you think that it has an end?
So some people also ask, where is the center of the universe?
Like, what is the start?
No one knows about that.
Shrotagan, welcome to your podcast with Raj.
गणपति बप्पा मौर्य। हेलो हाय नमस्कार आदाब, वेलकम टू योर पॉडकास्ट विद राज। इस साल के सेकंड शूट में स्वागत है आप सभी का। आई नो माफी चाहता हूँ, थोड़ी सी देर हो गई थी, बट हियर वी आर बैक विद द बैंग। वी आर नेवर गोना स्टॉप। टुडे इट्स अ वेरी स्पेशल एपिसोड बिकॉज फर्स्ट ऑफ ऑल आई एम सिटिंग इन फ्रंट ऑफ एन इंडिविजुअल जो इस वक्त मुझसे उम्र में छोटे हैं बट दिमाग में शायद बहुत बड़े। वाई आई एम सेइंग इट? बिकॉज ही इज जस्ट 22 years of age and he's written more than 10 books, one of which is a best-selling book under the category of science. He is Hiten Shelar, an astrophysicist and a science communicator, जो कि लेखक है. He's the author for Astrophysics for everyone, Astrophysics for non-mathematicians, and जो मेरे पीछे आप देख रहे हैं इस वक्त, the next level observer effect. I'm going to be talking to him about space, about universe, about time, about reality, about black holes, and ये कुछ Indian theme, Neil deGrasse Tyson, Joe Rogan, everything blended here in form of, two guys sitting here in Mumbai, chilling right now from my apartment studio, from your podcast with Raj, here in front of me, Hiten Shelar. Let's welcome the guy. How are you doing, buddy?
Hi there, Raj. How are you? It's been a pleasure being here, and really excited to talk about, a lot of stuff that, blends reality. I mean, stuff that plays with reality, Perfect. Really excited for that.
I hope I gave the introduction in the right manner. I did not, play with the bits around science and all.
No. You did it right.
First of all, tell me who's Hiten Shelar and how does he manage to write 10 plus books at the age of 22? Because I still remember by the time I was 22, I was just thinking of, oh damn, my college is over. What I'm going to do now?
So the first book I started writing, is like Astrophysics for non-mathematicians.
Okay.
And it was just not, I didn't plan it to write my first book like that. Okay. So let me tell you how it went, So firstly, I just used to randomly write what I used to think about the universe, or something like which I want to explain, like someone who is totally new to the subject. I just used to write it on the paper.
Yeah.
And then after that, I used to write blogs, posted on blogs. Exactly. Yeah. So after that, it came to mind. My little brother said that you have so many blogs, why don't you publish a book? And that, that idea just got me, oh my gosh, I can really publish a book on that. And first book, it's not there on Google. It's we have removed that book. Okay. So it's all about space-time.
What is that book called as?
It is, the name of the book is basically all about space-time.
All about space-time.
All about space-time.
As direct and as easy it can be.
Yeah, exactly. Yeah. But it was terrible firstly because, it was a compiled blogs basically. So what we did later is that I hired individuals and we just made it right, everything, just compiling it into a new book. Okay. Everything, we transformed into astrophysics for non-mathematicians. And, like after 1 year of hard working, we got into the international bestseller. And after that, my book Cosmology for Newbie came. And we have Astrophysics for everyone. We have Astrophysics in the form of a story. We have Imagine Space-Time. And my newly book right now. Of course, we have the next layer observer effect. Yeah. The next layer observer effect. And my new book, the Hyper Relativity. The speed of light is the speed of existence.
Okay, yeah. Hiten, we're gonna just, calm things down now.
Yeah.
I mean, I really admire the energy, by the way. Fantastic. I think it's just going to complement my energy here right now. But I want to start from the beginning.
Yeah, sure.
Like, just like the universe, when it was purely nothing, and then a bang, and then everything in creation, right?
Yeah.
We are all parts of reality today.
Okay.
But it started from nothing.
Nothing.
From scratch.
Yeah.
Like from basically as we say, infinite. You know,
Infinite.
it exists and it doesn't exist at the same time. Who's Hiten Shelar? How did he get interested in the world of space science, universe, time, light, reality? And how did your journey begin in this? What was the age when you first found yourself getting inclined to this space of science?
Well, I first went to the planetarium, Nehru Planetarium in
Yeah,
Mumbai.
in Worli.
Yeah, exactly.
Yeah.
So I went there as a 4-year-old kid, I think. And then I learned about relativity. I just heard about one thing about relativity, that time changes, Time for you is not same for me. If you go somewhere in the universe, or let's say in a high gravitational source or something, then time for you will slow down, and time for me, it will be a normal rate, but for you, it will be slowing down. So about theory of relativity, it's something which I've forgotten, as I went ahead, in school. But I was in sixth standard and I was watching on cartoon. There was one episode on that, on theory of relativity.
Which cartoon was this?
It was Doraemon. Yeah. Yeah. So there was an episode where the astronaut comes, and he's basically, the astronaut is around 23 to 24 years old.
Uh,
And that guy is welcomed by his grandchildren, who is basically older than him.
okay,
Who is
okay,
older
okay.
than him.
Yeah,
Yeah.
yeah.
So I was like, what's going on? I mean, what's going on? I was like, he might be not 24, but he was like 33 around. So he was welcomed by his grandkids. I was like, what the hell is happening here? So I got to know that, yeah, as a kid, I knew about the theory of relativity, and that day, I just got to know about it, I researched about it, and I got to know that when the clock, or when we move near to the speed of light, or whatever, when we, that day, I just read about it. When we start traveling, time slows down for us. As a kid, I was like 11, 12 years old
Okay,
kid.
okay. I mean, sorry to cut you here, but
Yeah,
for
yeah,
me,
sure.
theory of relativity was when I read about theory of
Yeah.
relativity, I read a simple quote by Einstein.
Yeah.
He said that if you sit with a beautiful girl for 2 minutes, it feels like you're sitting with her for 2 hours and you never want the time to end. And if you're sitting on a hot stove for
Yeah.
like 5 minutes,
Yeah.
but it feels like goddamn you have been sitting on it for like 5 hours. That's my understanding of theory of relativity. Like, how do you equate it with your understanding when you were trying to research about it, and now your understanding of it today?
So time does slow down for you, okay? Time does slow down for you. So once you, theory of relativity, if you talk about, let me introduce what is the theory of relativity
do that.
first. Okay,
Yeah.
let's do that. Okay.
Yeah.
So when you talk about space and time, okay, we know what is space. Okay. So what is a space? It's a location. It's a location. For example, let's say tomorrow you have a train like 7:30 in the morning. Let's say. Now the questions, there are going to be two questions which you're going to be asking. First, on what platform is my train arriving, and at what time? Okay,
Absolutely.
right? Without any of these numbers, like say you just know the platform and you don't know the time. Can you catch your train?
Definitely not.
And or if you know your time but you don't know the platform, can you do that?
I need to know both the things.
Both of the things.
Yeah.
So what you need the location, you need the time. So anything you describe in the universe, anything, it requires two numbers. Okay, so you need a location in space and location in time. On what time it is arriving. Okay, that's basically location of time. Location in time, I mean. And when we talk about location in space, it described by three numbers in this universe. Okay, everything has length, breadth, height.
Hmm.
Okay, so
Two-dimensional.
our universe is three-dimensional, right? So everything has to be, like in 3D space, everything has like three-dimensional coordinates which decides its location. Okay, which gives its location, I mean. So in this universe, you need three numbers of space and one number of time. So that this combo,
Okay, can you repeat that? 3 numbers of
space and one number of time,
time. Okay.
is what describes every single event of the universe. For example, we are talking right here. What location it is, what time it is. It's an event, right? I'm talking to you,
Hmm.
so it's an event, right? So every single event in this universe is described by these four numbers. Okay, first three is of space, and the fourth one is of time.
Hmm.
And this is what the space-time is all about. So the universe is basically this fabric of space-time. It's like a cloth, okay,
Hmm.
where you can look at it as fabric of space-time, okay,
Hmm.
where every single point, this gives an event which has three numbers of space and one number of time.
Yeah.
So that's what space-time is. And what relativity is all about, let me tell you, in reality, time is just same as space. Okay, what do you say? What is time? We feel time and space different, right? Space is location. What is time? But Einstein said, okay, that time is just same as space. Okay, it doesn't differ from it, but we feel it something which is not like space, right? Not like space, right? But time is just same as space. But so what makes space and time different? Okay, and now here comes the part of relativity. Okay, so listen me closely. Okay, the faster we move in space, the slower we move in time, and the faster we move in time, the slower we move in space. So that's basically a tug of war always happening.
Inversely proportional to each other.
Oh, yeah. Basically, yeah. So if you speed up in space, you slow down in time, or you speed up in time, you slow down in space. But tug of war of what? What exactly are we getting, on either side?
Huh.
Is the speed of light. So that's why things that travel at speed of light in space, they don't feel time
At all.
at all. They have to won the tug of war. Speed of light, let me tell you, it's just the tug of war entirely of, the speed of light. It's also called the speed of causality. C. It's mentioned by C. So this tug of war is all about that. Once you have the entire speed of light in space side, you remain with nothing on the time side. So just for light, light doesn't feel any time. If you ask like knock knock,
No,
like what
hold
is
on,
time?
hold on. What I want to understand here is, what if someone is traveling at the speed of light? What happens then? Like if I'm traveling at the speed of light in my daily life, what happens? What will I see, or what will the world see about me?
You will see everything happening at the same moment. For example, let's say you are first let's define relativity. I will come to that just after that. Is it fine?
Sure. Yeah.
Yeah. So in two parts in relativity is one special theory of relativity and one general theory of relativity. At the end of the day, it's all about this tug of war. It's all about this tug of war. So special theory of relativity is all about this tug of war between space and time. I define as I explained, what is space, what is time, and theory of relativity is just about this tug of war which happens between space and time. It's just all about that. Huh. So that's about the theory of relativity. And now coming to your question again, okay? You just asked me like how the world feels like, and when you travel at speed of light, how does the universe looks like? Okay, so imagine if time doesn't stop for you, have time has stopped for you. Okay, so what you will see is, let's say you went to school, you went to college, and now you're doing some now you are an employee. Okay, you're working at some job and some company, let's say. Okay, so if you are traveling at speed of light, time totally stops for you. So now you will say, right now I'm in the school. Right now I'm going in the college. Right now I'm in the office. So everything has to be there simultaneously. You can't say that I was in school, or you can't say I will be. Maybe like I will. Let's say, yeah, I will be like right now. Maybe let's say you are like 25 or 24. Let's say if you go, you can't say that I will be 50 years old. You are 50 years old right now. Everything is right now. Past and future doesn't exist. Only thing that exists is the present. So that's how the light witnesses this universe. Everything has to be there with no time delay. Everything is present. That's also called the omnipresence. Omnipresence. Everything
Because
which is
omni is
present.
light.
I know. Omnipresence is like, it's like everything present at the same time. For example, let's say there is no cause and effect. For example, if I have an apple, okay, and if I throw it, okay, I just drop it, okay. Now dropping the apple is a cause, and the apple falling down on the ground is an effect. It has some time delay, right? But when you talk about omnipresence, there's nothing called time, okay. So apple has been dropped and it falls down. It's just like it always there, okay. It's not two different states, in between some time is there. It's like already present. You are there, for example, you are there in school right now, you are there in college right now, and you are there in office right now. You are old right now. Everything's right now. No
I
time,
also
no
heard
future,
an
no past.
explanation by, I think, one of great advisors or scientists. I don't remember his name right now, but he said that, for example, if the light is falling onto us right now,
Okay.
and that light is traveling to some some celestial body or some planet outside
Yeah.
of our solar system, and at that time, when the light will reach over there, and if someone is able to see it,
Yeah.
if someone is able to witness this, even though if you're like 80 years of age over here right now, but the time when the light will reach over there, that person will be able to see this image, this current image.
Exactly. For example, if you go around like 68 million years, light years, I'm sorry, if you go like 68 million light years away from the Earth, And if you just point out to some hypothetical telescope, let's say, and you just point on Earth, you will be looking at the dinosaurs. That's what you're saying.
Yeah, I think so. Something like that. Because
So basically, you look
yeah.
in past.
Yeah,
Is that what you're saying?
I think so.
Yeah.
Because the light that fell on them is reaching them after 68 million years.
Yeah. So, but for light, the thing is that time doesn't exist. If you ask the light, for example, it takes 8 minutes for the light from the sun to reach here on
reach
the
us,
Earth.
yeah.
Okay. But if you ask like knock, how much time did you require to cover that distance? What will light say? I was always here as soon as I was created inside the sun. Always here, all time here. There is nothing after. There's nothing like after 8 minutes or after 1 minute. There is not even 1 second. After 1 second, it as soon as it was created, it was there. So that's the world of light, weird world of light. So that happens with the speed of
Yeah,
causality.
weird. But then why do we say that it takes 8 minutes to reach us from sun till here?
Because that there comes the complex part. Because if when something travels at speed of light in space, that rests in time. But when something is at rest in space, what will it do? It will travel at speed of light in time. We are traveling at speed of light in time. Yes, we are traveling at speed of light in time. Okay, so light is doing in space, we are doing it in time. It's like tug of war. And now since any speed, when you talk about mass, we all have some mass, right? Mass can never reach the speed of light. It can never ever reach the speed of light at all, because it's how it's made. I won't be able to describe it entirely. It will take a lot of time, maybe 4 to 5 hours for to explain it. But yeah, so anything that has some non-zero mass can never attain that speed. Okay, and so you can consider it as like at rest. So anything, it has a proper time. There's a term for that. Anything that has some non-zero mass. It's feels some proper time. Proper time means it is traveling at c in time in its frame of reference, no matter what. Even if it goes 99.9999% of speed of light, it's still traveling at speed of light in time in its own frame of reference. As you asked me, why it takes 8 minutes for the light to reach her. So look, we experience this universe in a pace, like how a time in a pace that our time is moving. Okay, so our time is moving at c in time dimension. Okay, so it's not that light is omnipresent. If you consider the higher dimensional thing, like for example space time. Okay, if you consider space time, light is omnipresent, it's everywhere. Okay, but we are paving our way at c, in space time. Okay, in time dimension. So it's either we who are interacting with light at the speed of light, not light interacting us. Light is already omnipresent in space. We are interacting with light at sea, and it appears like light is actually traveling, but we are.
Why don't you give us some examples or references for this? For example, I know Flash.
For example, let me give you an example. Okay,
Sure.
for example, we are traveling on a car in a car. Okay,
Yeah.
so like we have trees like around us. Okay, there's one tree there in front of you. If you travel at 60, if you travel at around like 60 kilometers per hour, let's say, and the tree will appear to move. So is it you moving or a tree moving?
It's we.
It's
we
you.
are moving. I mean,
It's
literally
you.
not even we moving because we are constant in one seat. It's the car, the body.
It's
that
a
we are
car
inhabiting.
moving.
Yeah.
It's a car moving, right? So similarly, if you consider the space time, it's a 4 dimensions, Raj. Okay, it's 4 dimensions. And something which we can't imagine. We can talk about it mathematically, but something we can't imagine. So in 4-dimensional space time, let me tell you. After this, I'll tell you about hyperspace and how weird 4 dimension is, so it can make sense for how space time looks like. Yeah. So when we talk about space time, right? So in such a diagram, it's not that light is moving, light is omnipresent, but instead it is us who are interacting with light at sea. At any specific point, we meet the light. So it's like, yeah, I observe the light. So we experience the world in an order or in a speed, like that is proportional to what speed we are moving in time. And what speed we are moving in time is the fastest speed of the universe. When something that has non-zero mass moves at c in time, all the time, that happens. So it's us who are actually meeting light, omnipresent light in space time. And yeah, like just that tree, it's not like tree moving, it's us moving. Similarly, we are moving at c in time, meeting the light exact moment. It appears like light is moving, but no, it's us who are moving. Let me tell you one very interesting example. Okay.
Yeah.
Now let's say you go on the terrace. Okay. And let's say you watch a light. Okay. Now,
What do you mean by watching a light?
like the sun, watching the sun.
Huh.
Okay. So when the light from the sun hits your eye.
Huh.
Okay. So now you will say that it takes 8 minutes, right, for you, without like knowing that what I explained just now. Okay.
Hmm.
So you will say it took 8 minutes for the light of the sun to hit your eye, right? But from the photon's perspective, it took no time. It was instant. As soon as it was created, it was instantaneously into your eye. So kind of it just appears like once the photon was created like millions of years ago, it takes millions of years for photons to escape the sun, even if it's created right there inside the sun. So it feels like millions of years ago, since photon is saying as soon as it was created inside the sun, it was in your eye. So does that mean that millions of years ago photon knew whose eye it was going to enter into? So that gets a lot of paradoxes. It takes like a lot of readings. It's been well discussed in my book Hyper Relativity, my new book. Yeah. So the subtitle of the book is "The Speed of Light is the Speed of Existence." I will also tell it why. Okay. The speed of light, the speed of
Okay, okay.
existence.
But I would like to take it, step by step.
Yeah, sure.
I think I really like the last example that you gave, like the photon that was created like some million years ago and then it hit, it was in front of your eyes. So did it know or did it not?
Yeah.
But, it was going to be there. Okay, just tell me, what is time? Samay kya hai?
Okay, Samay is like, as I said, it's just like dimension, like space. Okay, we just discussed everything has length, everything has breadth, and everything is height.
Hmm.
Now let's have a fourth one. That's fourth dimension, and that's basically time. And now, as I explained, why do we?
Einstein also said the fourth dimension. Yeah.
Time is a fourth dimension. Now we have four things, right? Three of space, one is time. But why does time feel different? That's what I explained. What is theory of relativity? It's all about that tug of war. We, as something that has mass, we are feeling time as something different because we are constantly traveling at time at speed of causality or the speed of light. We are constantly doing it in time, but we are at rest in space.
We are at rest in space.
Yeah. So basically, how light feels, that space-time is like totally different, like totally opposite, as like what we feel. Light travels at c in space, we travel at c in time. So, yeah.
See, the maximum that I can understand from a very visual reference point of view that I can is like Flash, the superhero, which travels at the speed of light, I would like to say, or faster than light. I don't know, he travels faster than light.
Superluminal travel.
Yeah. But then when we see him, traveling or like running or whatever he does, the things around him get super slow. Even though they're happening in real time, but they get in super slow motion. So do you mean like something of that sort will happen when you will travel at that?
Well, yeah, that's called a relativistic speed. So anything that is comparable to the speed of light, okay? Anything that is comparable to the speed of light basically feels time dilation. That's what we call time dilation. Time does slow down for you, okay? Once you hit the light, time does not exist for you, okay? But anyways, let's take it a bit lower to that, okay? Let's say we are traveling at 99.99% of speed of light. We do usually have the electrons and all those stuffs, in CERN, CERN. Yeah, so particle accelerator, where we accelerate, a lot of particles at near to the speed of light, and at such speeds, time is like near to zero. But okay, time is just a dimension. It's just about you. It's just about you slowing down in time. The tug of war. Once you speed up in
For
space,
example,
you
it's
slow down in
hitting
time.
on your face right now.
Yeah.
Okay, it is hitting on your retina.
Mm.
And no, basically it is hitting on you, and the light that is hitting on your face, you're the mass. It is traveling at the speed of light and entering into my retina. And my retina is able to generate that image, send message to my sensory nerves, and then the image is created, which is you, which is everyone sitting here in the studio, the objects in front of me right now. And same thing is happening with you. So, how does it work, basically, the entire concept of it, if I'm able to make sense? Like, if I'm trying to just understand, like, how does this entire scenario work and how will it change if, for example, you and me were at the speed of light ourselves?
We both are the speed of light, you're saying?
If you and me right now were both at the speed of light ourselves, so what about our surroundings? What will we observe right now?
Firstly, if we are at the speed of light, as I said, everything will be omnipresent. Everything like present, future, everything would be in the present. No past, no future. You are in the school right now. You are in the office right now. You are what you are right now. Everything is
So when the
omnipresent.
lights that occurred in that event come to us and we're able to witness it, we'll be able to see it. something.
Yeah,
that
but for light, it's always the same thing. But right now, let's consider about what light looks like at the speed of light, right? So I think, firstly, we can't never travel at speed of light. So forget about it.
I mean, what if we do? I mean, just a hypothetical case. I mean, what would be the scenario like?
Maybe we'll be looking at light if you travel exactly at sea. You know, I think, we'll be looking like as the same thing. I think this is my guess. Okay, like traveling at the same speed. Like you are traveling at 60 speed, and I'm traveling at 60 speed. Okay, so I mean, think everything is omnipresence, bro. I mean, everything is just like omnipresent. You wouldn't be like light is coming, light is going. Everything, light is hitting my face. All right, it's doing right now. Light may be gone there, light may be gone here. It's everything right now. Right now, everything omnipresent. Maybe this world is, I think, is hard to think about due to our familiar. I mean, we are very familiar with the time. We always discuss things in terms of past. We think in terms of present. We think in terms of future.
Yeah.
That's a habit, but it's really becomes very difficult to think.
Yeah, because I mean, what is present? Present is this. Like, it's gone.
Exactly.
It's gone.
If I tell you that's what I tell you. That's what I tell you.
I mean,
If-
I just don't understand the concept of time. Like, it is just in our minds. Like, how is it going since the time 3 lakh years before when the earth was started, or basically, I mean, that was million years ago, but when first humans started to appear, that was like 3 lakh, 4 lakh, years ago.
yeah,
And since then, time has just existed, and it has existed and passed at the same time. I mean, it is here right now, it is gone.
Yeah.
It's in the past. I look back, it's in the past.
Hmm.
So like
If I
we're
tell
just
you, yeah.
constantly traveling, we're just constantly moving ahead.
So yeah, I got you. So before that, let me just ask you one thing. If I tell you are in school right now, you will be offended. No, I'm not in school. Okay, so everything. If you think about omnipresence, okay, let me talk about omnipresence first. So omnipresence is all about future, present. Everything exists in present. That's our omnipresence. Now let's talk about time. You know, when was the first second got counted?
No idea.
At Big Bang. The creation of the universe is the creation of time.
Okay.
They is the creation of time. The creation of the universe is not just the creation of time, it's also the creation of the tug of war of speed of causality. Universe,
The
what is
creation
universe,
of
Maharaj?
4 dimensions.
Yeah, of space-time. Otherwise it's all was like hyperspace, infinite number of dimensions, 0 to infinity. It was just all of hyperspace, nothing like time. But what made space-time special from this hyperspace is that tug of war of speed of causality. Okay, the tug of war of speed of causality is what made things that have mass. Higgs boson given mass to the things, to few things, and to photons that didn't give mass to them.
Okay, describe photons, neutrons, electrons, like for any 12-year, 11-year-old right now who's just sitting in school and science and just wondering what are all these stuff. Because
Well,
even I'm confused.
Photon, let me tell you, light. Okay, when you know light. Okay, so photon is a quantum mechanical analog of light.
Quantum mechanical analog of light.
Light.
Okay, one photon.
A photon, a particle. Quantum. What quantum mechanics says is basically any field interactions. Okay, so let's say for example we have electromagnetic force. So that comes from the exchange of the photons. So quantum mechanics says that it's a theory that says that that describes the four fundamental forces of the universe, which we have the we have the gravitational force, we have strong force, we have electromagnetic force, then we have the weak force. Okay, so all of these forces are described by fields, but after quantum mechanics came, it described in terms of particles. So electromagnetic force, which you say, which comes of exchange of light, so quantum mechanics says that it comes from the exchange of photons basically. And also the double slit, not double slit experiment, the that Einstein, which is Einstein created for, that is what we call, we have iron slit. Okay, and yeah, so a photon knocks off the electron from the iron sheet. Okay, so that Einstein predicted it. So yeah, that's a photon in a particle form. And there are some things which can't be explained by wave form of photon, of light as a wave. What is it? It's electromagnetic radiation, right? That's photoelectric effect I'm talking about, Einstein. Okay, so you have a plate. Okay, and some things can't be explained by the wave nature of light. We discuss it as a particle. Sometimes wave, sometimes particle, sometimes wave, sometimes a particle. So what is light exactly? It's both. Sometimes it
Wave and
behaves as a
particle.
wave,
Okay.
sometimes it behaves as a wave, sometimes it behaves like a particle. It's both. So photon is basically that nature of light, particle nature of light. And light as an electromagnetic wave is what we all know, oscillating electromagnetic fields, electric and magnetic fields.
That's why
That's what light
Earth is
is.
also a very big magnet, revolving on its own axis.
The reason behind Earth's magnetic field is because we have some molten core inside. Okay, and as you go up to the surface, the molten material is not that much as you go up in the surface. So there comes like a lot of friction out there, and that friction and charge, it creates the moving electric field. What does it create? It creates a moving magnetic field. Okay, so the moving charges inside is what gives rise to the electromagnetic field, basically, of the Earth. Yeah. But yeah, as I said, electric and magnetic field both travel at speed of light, like light itself. I mean, but light is not different from them. Light is not different from electromagnetic field, and it travels at the highest speed possible of the universe. There are two things, if you will wonder, like how, like what things is it? Only light that travels at the speed of causality, the highest speed of the universe? No, there are two things. First, it is light. Second, it is graviton. You ever heard about graviton?
No.
It's when we talk about graviton, it's a particle nature of gravity. Okay, so Newton basically discussed about gravity like as a line of force. Okay, and what Einstein did, he did like explain in terms of like space-time curvature. Yeah,
Okay, I mean, you spoke about Big Bang universe. What was there before Big Bang happened?
hyperspace. That's what I believe.
What does it look like?
Let me tell you how our hyperspace looks. We have 3D world, Raj. Okay, just space. You can imagine that. Now, do you know something called Tesseract? If you watch the movie Interstellar, that's the ending scene of the movie Interstellar, where the astronaut Cooper, Matthew McConaughey, he basically falls into something weird looking room or something where he was having access to his past, present, and future, as well as he was accessing, like, it's sort of weird. Let me tell you what is hyperspace firstly. So hyperspace is nothing but traditional definition of hyperspace is dimensions more than 3. Okay, and what our universe is 4-dimensional. It's a hyperspace thing, something our mind can't perceive. Okay, our universe is a hyperspace thing. It's a 4-dimensional entity. So let me explain you how bizarre is hyperspace. Okay, so let's say let's take an example of a boy named Joe. Okay, so he came to his village, let's say, and he gifted his parents like a 10-story, like 5-story building. Okay, so it's like it has like 5 rooms in it and windows in it. Okay, now suddenly the earthquake came, let's say, and all these floors toppled on each other. They did not destroy themselves, but they just toppled on each other, like, and just superimposed into one single cube. And now they can see is like no mess, but just a single cube. Now, what happens in reality is that as the earthquake comes, this all the floors of top, there's the ground floor, and there's all the 4 floors above it. They fell into the higher dimension, into the 4th dimension. Now, let me explain you how it looks like. Okay.
So something that I read was that the 4th dimension basically begins downwards. Am I right?
No.
Okay.
It's more than. It's not just that.
For example, if this is the space
Okay.
and there's a ball rolling, like for example, this is space, right?
Yeah.
And if there's a ball just going around,
Yeah.
around. So what I read, I think this was again Einstein or something who said this, like, so it becomes like, it falls down and something pulls, and then this becomes the new space for it. So like this is the 4th thing, the 4th element or the 4th dimension that opens. Right?
Yeah, that
Might be
depends.
wrong,
So
but-
basically, if you imagine a paper, as a space time, let's skip 2 dimensions of space and just we have 1 dimension of space and 1 dimension of time. Let's call it space time, and that's a 2-dimensional flat paper.
Yeah.
If you just poke a hole in it, that becomes the height, and that height is, you can also consider as a 4th dimension. Yeah, but firstly, you are imagining this 2 dimension as the universe, but the universe itself is, as I said, it's 4-dimensional. Something, yeah. So let me tell you how the hyperspace works. You will be really shocked, because the thing is that our universe is a hyperspace thing. Okay, it's a high dimensional thing, and it should make sense. We should know that it's something we can't imagine. Okay,
It's something we can't imagine.
4-dimensional thing we can't imagine. We just can imagine at 3D scale. The human mind can't think of more than 3 dimensions at all. Okay. So where we at, the earthquake comes. Okay, and all those 4 floors above the ground floor, they topple each other, and like, they into a single cube. Now the Joe enters, and what exactly happened? So on the first floor, he was able to see his parents outside of the window. Okay, but he was like, there is no staircase going upwards. It was like rooms were like randomly arranged. Staircase were like flat totally instead of climbing up or climbing down. So he went to other rooms. The second room, what he saw, he was in London. Let's say Joe was in New York. Okay, Joe was in New York. Now in the second room, he was in London. He looks outside and he can see the London outside. Okay, now he goes in room 2, which is the third floor of the building, and he goes into that. He is in Mumbai. He can see the gateway of India. Yeah. So he goes in room 3, which is the fourth floor, basically, of the house, of the building. Okay. And he finds himself on Mars.
How the hell this happens?
Because let me tell you, okay? Now the fifth floor he goes, he's on the moon. It's an obvious question. How the hell does that happen, right?
Yeah.
Well, the house has fallen into 4 dimension. Well, let me tell you how it works, okay? Some 4
It's
dimension.
something like what we see in Doctor Strange when we see all the, the cities or the places itself, falling into one another and becoming baths of cubes. And then Doctor Strange is traveling in that. So it's all about time, right? With Doctor Strange, he plays with time.
4 dimension is not exactly time. Time is just a special case of 4 dimension. I'm just talking about the hyperspace. We're talking about what was before the Big Bang, okay? What was before Big Bang, there was no time, okay? There was a hyperspace. So I'm giving an idea of something dimensions more than 3, okay? So when you talk about the 4 dimensions, okay? So it is that bizarre. If you watch when a tesseract, there's on Google, if you check it, like there's a tesseract GIF image, okay, where they just rotate the tesseract and it already looks bizarre. But here's the point: it's just a shadow of a tesseract. Let me tell you, a shadow of what is the shadow of a tesseract? It's a cube. If I have a cube, Rubik's cube in my hand, if I cast a shadow right here, it will be like a square. But if you cast a shadow of a tesseract, it will be a cube.
Okay, the shadow will be of a cube. And how will that look like?
The shadow would be a cube. A cube is 3 dimensional. It will be a 3 dimensional shadow. When you project the shadow of a 3 dimensional cube, the shadow is 2 dimensional. Square. But when you project what you call tesseract is basically 4 dimensional cube. Okay. So when you project the shadow of the tesseract, you don't get the 2 dimensional shadow. You get a 3 dimensional shadow. Something we have never seen in our lives.
I mean, is this just theory or is this?
It is in theory. Of course, we can't imagine, more than 3 dimensions, but our universe itself is the 4 dimensions. It's 4 dimensional thing. Explained in this example of rooms, when the rooms topple on each other. We had such a bizarre things, right? So let me explain. How was they able to? How was in Mars? How was like that? Things like that. So the rooms travel. It does even if it like say for example, if a room physically traveled in 3 dimension, it would have like appear like it's flying somewhere in the air then it went to the London. It's not like that. The room actually traveled in the 4 dimension in London. Okay, it is in 4 dimensions, something which we can't see. Okay, so let's say if I'm here now, I can be there without traveling straight like to you. I mean, without I can just if I travel through 4 dimensions to you, let's say, it will be like a teleport. You will say, oh my gosh, you were
Yeah,
right
teleport,
here.
okay.
You just went somewhere and you just like are coming in front of me, right? Like what I will say, I traveled through 4 dimensions, and that's where the picture of wormhole even comes in. It's a
Okay. Hold on.
yeah.
Right?
Go ahead.
Okay, but all right. What happens once Big Bang happens, and why Big Bang happened? Like, if in just brief, if we want to understand, okay, what was Big Bang?
Big Bang is the start of that tug of war.
No, but explain it to me. Like, what happened? I mean, whatever scientists have discovered in so far so many years, what was Big Bang like? What was that occasion like?
Uh, it was not a bang. Like it was
What
not a
I
bang.
understand is that something exploded, Stardust happened,
Mhm.
and then off it we were born.
Mhm.
And then the planets that were exploded off our bigger star, everything became a part of it
Yeah.
and surrounded and became the solar system. Then it took a lot of time to cool it down
Yeah.
because it was very warm in the beginning. And then as and when it cooled down after millions of years, the start of life happened in forms of microorganisms.
Yeah.
And that's how we evolved into lots of species, and today we are sitting here as humans,
Yeah.
as Homo sapiens.
Yeah.
Is that what it is all about?
Yes, it's all about. If you talk about the plain, step by step, yeah, you can say that. But the Big Bang, very nature of Big Bang is like when it started from hyperspace, Before Big Bang, there was no time. There was space, what you call hyperspace, 0 to infinity. But the Big Bang starts space time. And what gives rise to the space time is that tug of war of C. Yeah. And relativity, in fact, is
What
all
do you
about
mean
it.
by it?
The speed of light.
Yeah,
As I said, the speed of
10 raised to the
causality.
power 8. Yeah,
Yeah. So it's basically 3 times 10 raised to power 8 meters per
second.
second.
Yeah.
Yeah, that's a large, that's a huge speed, right? That's a huge speed. So nothing that has, something that has mass can never travel at the speed. Only light does it, graviton does it. And yeah, so that's how it works.
And what if some person travels it? So like he can be anywhere and everywhere at the same time.
Omnipresent.
Wherever light reaches, he's there.
Exactly.
He or she is there, or it is there.
You can't say like, if I tell you this is the end of the podcast. No, this is what we are in the podcast. Can I tell you this is the start of the podcast? No, we already somewhere in the podcast. It's been long since we started, right?
What about the 44 minutes that happened in the past? Where did they go?
It's all here in the present. You can see us, both of us, talking about the topics we just did it like 20 minutes ago, let's say. It's all happening right now. That's the omnipresence. Our mind is not used to it. Come on, okay? Our mind is not used to it. We have to understand it better until we are getting, used to it. And yeah,
But
omnipresence
again,
is,
whatever happened for the last 40 minutes, where are they? Where are those moments?
well, if you're talking about whether
Somewhere
past
in
is
the
real,
light? It's somewhere in the light.
some people say, no, it's not somewhere in light. Some people say that information of the universe is the come. That's the information, right?
Because tell me, the moment that happened, this
Yeah.
moment that happened,
Yeah.
now it's gone. It's in the past.
Hmm.
But the light hit you, and it is traveling somewhere.
Yeah.
The ones that entered into my light gave me that image, but the ones that took that along with themselves. So if that travels and goes on to another celestial body, and if that person of that entity over there sees that light, so it will be able to see us in that
Yeah.
moment.
Yeah,
Right?
basically,
Am I making sense?
I mean, if you are saying that if light, like give an example, you are looking at the past. Basically, when you look at the universe, you are looking at the past. That's what you're saying, right?
Yeah.
Yeah, that makes sense. But for light, as I said, it's all in here. But yeah, you are looking at the past.
So what I'm understanding is that when you say omnipresent or omnipresence, it's basically the past, future, and the present all hanging at the same time.
Exactly.
It's all about hyperspace.
It's all about hyperspace. Exactly. Everything that exists in hyperspace is all omnipresent. In fact,
It's all one and the same.
my book, I explain that, and when I'm going to talk about Big Bang, okay, let me tell you, okay, yeah. So Big Bang, Big Bang is basically, as I said, is a starting of that tug of war between basically between space and time. That's the starting of a tug of war, right? So even it's the subtitle of my book, Hyper Relativity. It's all about that. How the universe became special from the hyperspace. It's because of that tug of war of C that happens all the time. And that's about the theory of relativity itself, okay? Theory of relativity is all about this tug of war. So that the subtitle of my book is The Speed of Light is the Speed of Existence, okay? Because it's all about that tug of war.
The speed of existence.
Speed of light, the speed of causality, basically, is the speed of existence. And hyper relativity, the universe is nothing but that tug of war or speed of light in hyperspace. That's why hyper relativity. And that tug of war is nothing but, as I said, it's the relativity itself. The topic of theory of relativity is not just about time dilation, length contraction, or maybe a space-time curvature. It's about that tug of war that happens between space and time, the tug of war of C, the tug of also known as speed of light, also known as speed of causality. That tug of war is all about relativity. The topic of relativity is all about that tug of war. So the universe is nothing but a relativity in hyperspace, basically. So the name of the book, yeah, the hyper relativity. And yeah, as you said, this is how in hyperspace everything is omnipresent. Yeah.
Okay, Hiten. I think fantastic. I'm still trying to catch up on that.
Yeah.
Hopefully, my speed increases with respect to catching up to those concepts. But do you think, are you still learning? Are you still evolving? Or have you gotten a good grasp of all these things? Or are you still studying every day?
Relativity, of course, I'm doing some research on it. Of course, there are some topics I'm researching on, but yeah, I have a good grip on it. Of course, I do have a good grip on
But at such a young
relativity.
age.
Yeah.
And what do you think is there for you in the future? because somewhere it's already there.
We have a lot of plans, a lot of plans of books right there. And, a lot of plans we have, about relativity and about even, it's not about just relativity, about quantum physics, about astrophysics, black holes, a lot of stuff.
Today we are recording this podcast on 14th of June.
Yeah.
Today we lost Sushant Singh Rajput, which was once again, himself the biggest champion of quantum physics
Oh,
as we speak.
yeah.
It's been 5 years. I mean, tribute to him. Kudos to him.
Tribute to you.
Yeah. May his soul rest in peace. That's all.
Yeah. Rest in peace.
Okay. So when Nikola Tesla, he said that if you want to understand the world,
Mhm.
or if you want to, understand everything that is around you, think in terms of frequencies.
Waves.
Yeah,
Exactly.
think in terms of waves, think in terms of frequencies. What is that about?
Well, when you talk about particle and wave nature, what quantum physics is? Everything is wave. When you talk about, we just talked about quantum physics when we're talking about light, right? We're talking about light sometimes behaves like a particle, light sometimes behave like a photon, and sometimes behaves like a wave and sometimes behaves like a particle. Graviton also does it like, as a particle. We discussed it. But what about the idea that not just graviton, not just photon, but every single thing, the reality itself is a wave. So that's what quantum physics says, okay? That everything is a wave, and what collapses the wave function is the measurement we make. Okay, so for example, in photoelectric effect, we know photosynthesis in plants. Okay?
Yeah.
So for photosynthesis, light is required to be behaving like a particle. That's what knocks off the electron, and then further the photosynthesis process go
Help
on.
the plant grow.
Exactly.
Yeah.
So the process of
To think
photosynthesis go.
that sense, then we think about light as a particle
Exactly.
or like as an acid. Or
Like a
resource.
particle.
Yeah,
Like a
for
particle.
example, something for like if you're making a sabzi, so we add some particles in it to make it. So we think it in that sense. Yeah.
Yeah. And when you talk about, let's
So
say,
sometimes it's a wave, sometimes it is a particle.
when it's wave, let me
Yeah.
explain you. Let's say we have sunlight into your house, okay? If
Mhm.
you just keep a tiny slit, okay, of a window open, okay, and there's where sunlight coming, let's say, then you can feel an interference pattern on the wall. So that can be explained by a particle. Let's say I have a ball, okay, I have a slit. If I throw a ball through a slit, the ball is destined to be hitting right at the same, right on the wall on where the slit is projecting, on its area on, right? But what about waves? Wave doesn't work like that way. If you just pass the waves through it, the waves will show an interference pattern of different bands of light. So in this case, in this double slit experiment or single slit experiment, whatever you say, light behaves like a wave. But in some instances, it does behave like a particle. Like in photoelectric effect, it does behave like a particle. In photosynthesis process, you need light to behave as a particle. Okay, so sometimes it behaves like a wave, sometimes it behaves like a particle. But what quantum physics says that that everything is wave. Okay, everything is
So
wave.
when we say everything is wave, do you really believe when we have everyone saying like talk to the universe, it listens to you?
I agree to Nikola Tesla. Yeah, I think not maybe yeah, of course I do agree. Yes.
No. I mean, what I mean to say is over here, like people say, like you talk to the universe, whatever you have inside you, whatever you want, you put it out, you emit it out, because this tongue, that's like that holds your prophecy.
Yeah.
That's your power. That's your language, and whatever I'm speaking right now, it's frequency. It is
Yeah.
going out. It is becoming a part of the universe. It is somewhere out there. In the
Right.
it is like a particle, or it is like a wave traveling out, and it is sending messages to the bigger universe or to the future or to an existed past, whatever it is. So do these things really work this way when we emit out frequencies? Because they say like, you meet someone who vibrates at a higher frequency, and then you meet someone who vibrates at a lower frequency, and you ultimately end up connecting with those individuals whose frequency match with yours.
Well, firstly, the frequencies in physics we talk about the frequencies, like some book says that human give out those frequencies and all. That's how we connect the universe. I don't believe in it.
You don't believe.
But first, just wait a second. There's a book like just behind you, my book, The Next
Yeah.
Level Observer Effect.
Correct.
It doesn't deny the end result. It denies the process.
What is the end result?
End result is the same thing, like we are the creators of life, and like the observers have the influence on the universe. Yeah, not through frequencies. You're saying that the process is not what I believe in, but the end result is what I believe in. Now let me tell you how.
Hmm.
When you talk about this universe appears to be, when you talk about observer effect, let me tell you about my book. Okay, so observer effect is seen as something like there's a wave. Okay, electron, for example, some people understand it like it's a misunderstanding. Okay, some people see like if an electron is wave, if I look at it, it behaves like a particle, or and when I don't look at it, it behaves like a wave. That's a misunderstood version, but that's not the correct thing. The correct thing is that the electron behaves like a particle when it's under the cause of the observer. Okay, for example, even if observer is not present there, the electron will collapse from wave to particle under the cause of observer. It's not that observer looking at it. Even there are some people ask questions like, is there a moon if nobody watches it? Is there a moon? Of course it is there, but it's not, it's just it's just they are just exaggerating the things. So the thing is that
The moon doesn't has its own light. It doesn't emit light. It gets reflected.
that's not it. I'm talking about the existence of the moon. What happens if the moon doesn't exist?
What happens?
You just lost, the moon has created a bulge of tides, on both the sides of earth due to the tidal gravity. If the moon goes off, we have like a lot of tides coming here, like tsunamis will come, floods will come due to tsunamis.
Yeah, that's why they say like when the moon, it creates those
Yeah.
ripples or those tides, according to its um direction or whatever it is.
Yeah,
As it goes up, as it goes down.
yeah. But the thing is that you don't need to require to look at the moon for it to exist. Okay, the moon exists under the cause of the observer. The universe works under the cause of the observer. The term under the cause of here is very important. It is elaborated in the book. People just misunderstand observer effect, and it doesn't make any sense as well. Okay, according to physics, but the universe works under the cause of observers.
So when you say that you don't agree with the process but the end result, so that's how it comes. Ki like it works under the cause of the observer, which are we, but the process is different, but the end result is not.
That's what I meant from it. So everything is a wave, fine. Everything is like, infinite possibilities. But what makes that possibility? A wave is a possibility, okay? So for example, let's say, there is an electron wave right here in the front of me. Now electron can be here, electron can be here, electron can be here, any position. But why does it chooses a single outcome? Well, that happens under the cause of the observer, for example, let's say in my next level observer book, that happens under the cause of the observer. So yeah, so this is how it works.
Okay. What's space like? What's space for you? Do you think that it has an end? Or when we say it is infinite, what is in that infinite space? Because
Okay.
we are just part of one solar system, which is part of one Milky Way galaxy. Sun is again just a small star in front of a much larger star, much bigger star. There are bigger stars than Sun, definitely so many millions, trillions, we do not know. How does it work? So there's a very famous reel on Instagram that I keep on seeing that, that how big is the universe, to just flirt with your imagination. Then you see the Earth. Then you go and you see the sun. Then you go and you see the solar system. Then you see a bigger layer of it, where we all lie. And then you see even a bigger layer than the Milky Way galaxy. Then it becomes again a part of something else. Then they keep on adding up the layers, and then it becomes one globe or like one universe in itself. And then there are so many universes like that out there. So like, what is the end for it?
I got you. So if you're talking about the expanse of the universe,
Yeah, like the start or the end, what is it?
exactly. So you are asking, where are the boundaries of the universe?
Yeah, where are the boundaries?
Yeah, you can also ask, some people also ask, where is the center of the universe?
Okay,
Like-
what is the start?
Some people ask, I'm telling you that some people ask this question, where is the center of the universe? Both of this question, like where is the boundary of the universe, or where is the start, or where is the center of the universe, are the wrong questions. You know why?
Why?
I explained you. The universe is a space-time. Okay. So let's say there's a center point of the universe. Okay, center point of the universe. So that center point is just not a location in space. It's also a location in time, right? Because it's a space-time thing. Universe is a space-time manifold. Any point on it basically just does not represent a point in space, but also a point in time. It represents an event. So the center of the universe is not. It's not asking. It's not how it works. You can't ask where is the center of the universe. You should ask what event is the center of the universe. So center of universe is not a location in space. It's an event. So that event can be us talking in the podcast. Who knows? And when you talk about where are the boundaries of the universe? Now on a space time, when you have two points on space time connected by a line. Okay, imagine space-time as a paper. Okay, on that paper, you have like you draw a line on it. Okay, so any connecting 2 points, a line connect 2 points. Okay, so any line on that can is called as world line, a world line. Okay, yeah. So a boundary of the universe is just not like where, it's not about where, it's about what. It's a world line basically. It's a boundary that connects two events. Okay, so that's what the boundaries of the universe is. And to be honest, when you talk about where are the boundaries of the universe at the first place, we are constantly, as I said, we are constantly traveling at speed of light in time. So if you ask me where are the boundaries of the universe, here it is. I mean, it's present here itself. For example, let's say, can you give me a paper? Can you pass me a paper, please? So Raj, let's say, as we have this paper. Okay, here, let's say I'm traveling at, you know I have this arrow here. Yeah, so I'm traveling in this direction in time at speed of light. Okay, okay. So, okay, we can see the arrow on this paper, I think. Okay, so now this is the space-time universe. Okay, this paper represents here the space-time universe. Okay, now the boundaries of the universe is something which, if you go after, you will just be out of the universe, right? That's what you think. But this is 4 dimensions. Okay, 1 dimension of space of paper here, and 1 dimension of time in this 2 dimensional thing. Okay, so the best way how to escape the universe,
No, I really want to know.
just go into the extra dimensions. Just go into the extra dimension. That's how you escape. And when you talk about these boundaries of the universe, the edges of the paper, they are just not the location in space. And firstly, as we know, our universe is expanding itself.
It's always constantly moving and expanding.
Expanding, exactly. The galaxies.
I mean, we are not in a steady state or a constant space. We're always moving ahead, and with sun, with our entire solar system and the entire universe is constantly expanding, expanding, expanding.
Not the distance between our sun and Earth, basically,
but the space that we are covering.
Space, exactly. It's not just expanding. What is happening, Raj? The space is getting created out of nothing. Okay, it's scaling out of nothing. Okay, we have nothing to space getting created in every place of the in everywhere in the universe. Okay, so that, and it is the expansion of the universe, to be honest, is what is not noticeable even at the scale of the solar system. It needs like lights of like many light years it takes to actually feel the expansion of the universe.
No, and who feels it?
The galaxies. The farther we go, when we see in space, out there, they were looking at the galaxies which are like very far away from us, like tens and like thousands of light years away from us. Those galaxies like move, receding from us, at speeds comparable to the speed of light and even faster than the speed of light. I will say, how can those galaxies move faster than the speed of light? As I said, the speed of light is the absolute speed limit. Nothing can cross it. But it's not that they are doing it locally, they are doing it globally. Okay, what that means is the galaxies, there is a difference between traveling and receding. Okay, there's a big difference between traveling and receding. Nothing in this universe can travel at the speed of light or more than it. But if the universe itself is like giving that expansion effect of faster than speed of light, then of course the galaxies within it, it appears that it's traveling at faster than speed of light, but that's not the definition of a travel. Okay, yeah, so you can still say that it's not traveling at speed faster than c or c.
So when will it stop expanding?
No one knows about that. No one knows about that.
So it is limitless.
It's limitless. It's limitless.
And it will keep on getting created every time.
Even it's a lot of spaces. It creates itself all the time. All the time.
I mean, what is there? What is there? It's just dark hollow space, that's all?
Space, yeah. Space-time in the universe, empty space, now you talk about the empty space. Okay, so let me tell you, what is the temperature of something. Let's say we have a square. Okay, let's say I have a cube in my hand. Okay, and this is the void. Okay, something is somewhere in space and there's nothing in it. What would be the temperature? You will say 0, because there's nothing in it, right? What's the temperature is associated with the kinetic energy of the molecules, right? Or the movement of the molecules inside, right? So if there's nothing, there's 0 temperature. But no, that doesn't have it. We can't call the empty space totally empty. It's not totally empty. There is something we call the 0 point energy. The 0 point energy. It's a quantum energy which is there in every point of space-time, every single point of space-time of the universe. So as the universe get expanded, new space-time points come into the existence. This space-time point is accompanied by that quantum zero point energy. Okay, so you can't say it's just nothing there. Nothing doesn't exist in this universe, to be honest. Nothing doesn't exist at all. There's always some zero point energy associated with that particular point. And how does that zero point energy looks like? It's like, you know that an electron, do you know a positron? A positron basically is an antimatter version of an electron. Okay, but totally the same mass but totally sign switched. Okay, and same charge, I mean opposite charge, and yeah, opposite charge but the same mass. So they come out of nothing and they come close to each other and they annihilate each other, like, so that's how I think I'm going too complex, but okay, fine. Yeah, so that's how zero point energy looks like. Okay, so, to be what should the audience take is that the universe, however huge it is, it's not empty at all. Not empty at all. The zero point energy is there even in the somewhere where there are no stars, no planets, no dust, nothing. Zero point energy is there all over the
You spoke of
universe.
dust. What's a stardust?
Stardust.
Yeah.
I mean, like a lot of stars, like our solar flare and all those. We have our own sun's dust, like bombarding with the Earth all the time, which we get, aurora borealis on the north poles, northern lights, which you talk, which you say call it like, yeah, northern lights. So it's just that. I mean, there's a gravitational tug of war going between in the sun. So in that in that tug of war, solar flares occurs and all those things happen due to the magnetic field. Solar flares are due to the magnetic field.
Hmm.
And when that happens, tons of materials, thousands of tons of materials, like, get ejected out of the sun. And that's what is called stardust, right?
Do you believe, like, I mean, what are some of your peers, I would say, or some of the individuals that you look up to? Neil deGrasse Tyson?
Yeah, Neil deGrasse Tyson.
Because he's an
Of course,
astrophysicist
of course, of
himself.
course.
Yeah.
Of course, Neil deGrasse Tyson it is Michio Kaku. It's again like Stephen Hawking. It's like Michio Kaku is there. I mean, Neil deGrasse Tyson. Again, like there are a lot of people.
Okay, so what I mean to say is, what is that one, what's that thing that you like about them? Like, what do they talk about that really interests you?
Well, relativity is, I can't say, when you talk about the study of the universe, astrophysics or whatever, every topic is equally fascinating and they excites me all. But yeah, I mean, right now I'm much interested to talk about relativity right now due to my hyper relativity, my new book.
Okay, just describe your books, all that you've written in simple sentences. What do they speak about? What do they talk about?
The main
For our
motto,
audiences.
the main motto of my books is to make it available for the general audience. Okay, so it's my first book, Astrophysics for Non-Mathematicians, for the people who
Which is
don't.
the best-selling book.
Yeah, people don't like mathematics but like physics. It's for them. Cosmology for a newbie is again for them. For Cosmology for a newbie, a bit of astrophysics and cosmology both combined. And we have Astrophysics for everyone. Like if I have some friend, he doesn't know an A of astrophysics, I will give that book to him, saying that, okay, you should read this. This is Astrophysics for everyone. Astrophysics in the form of a story is something which I had written for my little sister, because whenever as a kid we used to sleep together. That time, I used to tell her about the stories. Actually, like, I mean, I used to explain her astrophysics concepts, like when I was like 5 years or 10 years ago. Like I used to explain her like stories, in the of I'm explaining the astrophysics concepts in the form of a story to her. So I was like, there are a lot many sisters there in around the world of mine. Okay, so I have to explain them too. So I just written my book Astrophysics in the form of a story. We have the Next Level Observer Effect, amazing book, legendary book of mine. I really love it. And we have hyper relativity.